I'm here with Dr. Romano to do a problem on limiting reagents.
Hi, I'm Dr. Romano. I'm professor of organic chemistry here at Romano Scientific and the creator of the Orgoman products in the DAT Destroyer book. I want to go over a question with you today involving limiting reagents, and I'm going to actually combine it with a gas law problem. So come along and let's have a look. This is a must-have type of question for the DAT. What I'm going to do is I'm going to take calcium carbide and put it in water, and we get calcium hydroxide and acetylene. So it's a wonderful way to generate acetylene gas. Now, what we first want to do before we ever do anything is to make sure the equation is balanced. 2 carbons and 2 carbons. There's a calcium on both sides. There's 4 H's on the left, 4 on the right, and we have 2 O's on the left and 2 O's on the right. So first and foremost, always make sure and never think that it's a given that an equation is correctly balanced. Now, at 25 degrees Celsius and 0.950 atmospheres, we have 128 grams of the calcium carbide, molecular weight given, and 45 grams of water are reacting. And I want you to first find the limiting reagent. Whenever they give you 2 amounts of starting material, one of them is going to be the limiting reagent that controls the reaction. Here's a nice little trick on how to do these questions. You first write the given. You have 128 grams of calcium carbide. A mole is 64 grams. It was nice enough to give that to you. And that gives me 2 moles of calcium carbide. And the way I teach my kids to do it is write the word have. This is what you have at the start. Then you took the 45 grams of water, convert that into moles, and that gives me 2.5 moles of water have. Now, what we need to do is what I call the test for the limiting reagent. What I do is to take the very first one that you see and write down 2 moles of calcium carbide. Now we look at the stoichiometry. There's 2 moles of water for every 1 mole of the calcium carbide reacting. And that would give me 4 moles of water, but the trick is to write the word needed. So you're going to remember, you're going to write the word have for what you start with, and then once you do this little test, you write the word needed. We need 4 moles of water. We only have 2.5, so the moles of water limits, means it runs out first. So therefore, water is the limiting reagent. All right, let's do part B on this blackboard. What I want to do on part B of this problem is to find the volume of C2H2 at these conditions. We're always going to assume a gas is an ideal gas, unless otherwise noted. So I write down PV equals nRT, and the volume is nRT over the P. So what we're going to do is we're going to convert the temperature of 25 into Kelvin. The pressure is already in atmospheres. The R is given. We need to get the moles of the C2H2. So you're going to take the moles of the limiting reagent and look at that stoichiometric relationship. So you have 2.5 moles of water. There was 1 mole of acetylene produced for 2.0 moles of water, and that gives me 1.25 moles of acetylene. We take that moles and put it into the ideal gas law. Don't worry about the numbers not being so nice in the destroyer as well as the actual DAT. The numbers will be even easier than this, but when we did the calculation, it's 32.2 liters of acetylene. If I ask you to draw C2H2, hopefully you can draw this in a slam dunk. That would simply be acetylene. Let me make this a little nicer. And there's your triple bond. That would be C2H2. All right, that wraps it up on a nice type of question you're going to see for the DAT exam. All right, see you in study group. Bye-bye.